So I know the other definitions that people were struggling with were the differences between a parameter and a statistic. But importantly, actually, is all four of these: population, sample, parameter, and statistic. So let's think about these four terms, because these are four terms that are going to come up over and over and over again. And if you get to Unit 3, like the third test, and you don't have these words down, a lot of these things are going to go over your head. So let's talk about it. First, population, as we've seen in red, it's all of the data that we're interested in considering. Everyone, everything. And as you saw, the word census means if we actually go through and collect all that data. Now, if we didn't have all that data, we would call it a sample, where it's only some of the data. And so or you can think of it as like a sub-collection. There's a subset of those people. So if we have everyone, it's the population. If you have only some, it's a sample. Now, one thing about this is it's the data. So when we're looking at these things, what we should be actually seeing is a list of all that data, or a list of those observations. Same thing with the sample. It would be a list of all those observations, a lot of different numbers or observations. If it's yes or no data, then it'd be yes, yes, no, no. If it's numbers, it might be 61, 63, 62. So when we have those lists, that's the population or the sample. Now, obviously, having a list of all these numbers is really difficult for us to kind of analyze, because it's just a bunch of numbers. It's hard to make any kind of conclusion when you have a whole lot of numbers. Imagine just staring at a list of 1,000,000 numbers. What do we do with that? Well, what we do is we try to measure all of those numbers using a single value. And so that's what parameter and statistic are. Those things are single numbers or single values that measure our data. So what's the difference between a parameter and statistic is the fact that a parameter will measure a population. So notice P for population and P for parameter. They go together. Same thing, a statistic is just a single number, not the list, but it measures the list of a sample. So again, S for statistic, S for sample. It's a measurable characteristic of a sample. So let's take a look at one example really quick. So in this situation, it says something like, we want to know the proportion or percentage, they're the same thing, the percentage of California who will be voting for Mr. Lewis in the next election. And we call 50 random numbers in California and ask, are you planning on voting for Mr. Lewis at the next election? So if I wanted to identify these four things that we're interested in, let's start off with the population and the sample. So first, our population, remember, it's everyone or all of the data that we're interested in. Well, everyone that we're actually looking at is all the people actually going to vote in California in this next election. More specifically, actually, it's their decisions. Because I don't want the names of the people, but what I want is a list of how they're going to vote, meaning yes, vote for Mr. Lewis or no, Mr. Lewis. It'll be a list of yeses and nos. Because we're asking them, are you planning to vote? Well, they're going to answer either yes or no. So if I have that list of every single person voting in California, then yes, we have the population. Now, of course, we're not calling everyone. We're only getting 50 random residents in California. And so again, we're looking at their votes. Now, if we didn't say their votes and we just talked about the people, that's totally fine with me. But again, it's key to understand that what we have is actually their list of yeses and nos. And because it's only 50 random residents that we're actually calling, this is not everyone we're interested in, but only these 50, we call that a sample. So again, it's only some people, so it's a sample. Now let's break it down into parameter of interest. What is this parameter that we're interested in? Well, it says it actually in the very beginning. We want to know what proportion or percentage of California will be voting for Mr. Lewis. So that's what I want to know. I want to know this single number. I want to know what's the percentage of everyone that's voting for Mr. Lewis. Well, that single number, that percentage, is a measurement that kind of gives us a gauge of how many people are voting for Mr. Lewis. So it's one number, it's a percentage, and so that would be our parameter. Now notice in the wording, it's actually saying parameter of people voting for Mr. Lewis in California, meaning out of everyone voting. Now notice in statistic, though, this is exactly the same thing. A statistic and parameter, they should really be the same. A statistic is the percentage also of people voting for Mr. Lewis, But we're not talking about everyone in the population. We're only talking about the people in the sample. So they're both percentages of people voting for Mr. Lewis, but the statistic is only out of the 50 random residents that we selected. So notice, the parameter measures everyone in the population. The statistic measures only the people in our sample. And that's the difference.